Hello everyone and welcome to our channel AKU Explanation. So this is our part 8 of matter in our surrounding, and this part will be definitely our last part of this chapter. So I hope that you must have watched all the parts, that is part 1 to part 7, before starting with this part, because in this part I'm gonna do some of the questions which are given in blue color of your NCERT book. So let us begin. So here I have some of the questions for you. I'm not doing all the questions because most of the questions are very easy, but there are of course some questions which you may find difficult to understand. So I'm going to give a brief discussion and like all the important points which are required to understand a question very well, so that you could cover all the different areas which are related in a question. So this is the first question. You can see here that the smell of hot sizzling food reaches you several meters away, but to get the smell from cold food you have to go close. Give reason. So you must have observed this thing also, that if your mother is cooking something in the kitchen, you get the smell of that food in your room. But if that food is not like in process of cooking, or else if it is put in a container and it is otherwise you can say that if it is in the fridge and you open the fridge, do you get the smell of that food? No, because that food is now cold. So why does that happen? That a cold food can diffuse the smell of its like aroma to several meters, but to get the smell of a cold food you have to go close and then smell. So why does this happen? So let us understand this. I told you that when temperature increases, kinetic energy also increases. When temperature increases, kinetic energy increases. That means temperature is directly proportional to kinetic energy. And when kinetic energy increases of particles, what happens? Particles start to move randomly. Yes, randomness increases when kinetic energy is given to some particles. Here you are increasing the temperature because hot sizzling food is given. That means the temperature is high. So kinetic energy is going to increase. So when kinetic energy increases, then what happens? Randomness also increases of particles. So when randomness increases, that means they are going to move faster from one place to another. So these are the particles, right? And they are going to move faster from one place to another. So this will cause diffusion of the particles. Diffusion from higher concentration to lower concentration. Where is higher concentration? The food, you have a food here in the plate, the kinetic energy is increased, so the vapors are produced. So here the concentration of the smell or the gas or the vapors of the food is high, but in your room the concentration is low. So this gas is now going to move from the higher concentration to the lower concentration. Due to increase in temperature, the kinetic energy of the particles increased, due to which randomness also increased, and that is why diffusion started. So I hope you understood this question. Let's move on to the next question. A driver is able to cut through water in a swimming pool. Which property of matter does this observation show? When this is your water and this is your diver, okay? Try to understand, like this is your driver, right? And this is this person is swimming in water. So why does this happen, that a driver is able to cut through water in a swimming pool? This is also easy only, but you need to understand that what actually is happening. Just suppose that you have a wall here, yes, and you have a man here. You tell this man to cut through this wall. The man is the man will be able to cut through this wall? No. Why? Because wall is solid. And when this man goes to swimming pool, the same man is now able to cut through the water which is given in the pool. Why? Here you have to go to the first like topic, first part of this chapter, in which I explain you why all these things are happening. Because in solids, the attraction between the particles is very, very high. Yes. So since the particles are very close to each other and their attraction is very high, so when this man is asked to cut through this wall, he is not able to do so, because there is no space into which this man could enter and cut through the wall and come at this place. There is no space. But in water, you know that the particles are, of course they are close, but they are not as close as they are in solids. So they are a bit far from each other. So when a diver comes here, he is able to cut through the swimming water, because there are spaces present between the particles of water. So this is the second question. Let's move on to the third question. Why ice floats on water? First of all, let us understand the question. Ice is what? Is solid, and water is what? Liquid. We know that solids have high density and liquids have low density. But still, when we put this ice on above the water, this ice starts floating. It does not immerse in water, it does not sinks into the water, but it floats. Why it is happening? Because if you have just suppose that you have this amount of water and you allow this water to get freezed, and this water formed this much small size of a cube. So what does actually happen when this water is getting converted to ice now? So it is forming a kind of cage-like structure. Cage-like structure. These are the particles of water, and it is forming some cage-like of structure. And what happens is, when this cage is formed, there are a lot of space between them. Yes. And due to this space, the density of the ice decreases. There are a lot of space between the particles of ice when it freezes. In water, the particles are close. But when we freeze this water, these particles, they become very far and form some cage-like of structure, due to which the density of ice decreases, and due to which the density almost comes equals to that is of water, or somewhat less than water. So when you put ice on water, it starts floating. Next question we have: why does a desert cooler cool better on a hot dry day? Why does a cooler works better on a hot dry day? To understand this question, let us begin with evaporation. Okay, so what were the factors which were affecting evaporation? Temperature, humidity. Here we have to consider these two factors only to understand this question. In a hot dry day, temperature is what? Higher, because it is hot, so of course the temperature is higher. And it is dry, means there is less water vapor, less water vapor in the atmosphere. That means humidity is what? Low. And you know that these two factors, that is temperature is higher and humidity is lower, these two factors are responsible for increasing the rate of evaporation. So since on a hot dry day the temperature is also high and humidity is also low, so desert cooler, when when you switch on the cooler, wind is blown, and you know that when wind is there, then evaporation process increases. So cooler is providing you wind, and due to hot and dry day you have a higher temperature and humidity is low, so of course the cooler is going to work better and evaporation process will be high. Your sweat will be evaporated soon and you will feel cooler. Done. Next question. How does the water kept in an earthen pot means matka, become cool during summer? Why does this happen? That when you put some water in the matka, you are putting some just suppose that normal temperature water, but after some hours you will notice that that same water, the temperature has gone down. Without the use of refrigerator, the water is cooled. Why does this happening? Because the earthen pot has some small pores on its surface. Very small pores on its surface. So when you pour water in the earthen pot, the water particles which are in contact with the surface of the water pot from inside, they start evaporating since it is during summer, so the temperature will be high in the surrounding, of course. So when these particles will come in contact, just suppose that this is the surface of the matka and these are the particles, and some particles of water are here also. So these are in contact with the surface of the matka, and here the temperature is high on the surface, so these particles will start evaporating, and you know that evaporation causes cooling. So when evaporation will occur, so cooling will occur here. So the particles inside the water which are inside the matka, they will start they will start decreasing their temperature, so they will start cooling. So this is how a matka works as a refrigerator in rural areas. Next question. Why are we able to sip hot tea or milk faster from a saucer than a cup? You must have observed this, that when your mother gives you some milk in a glass or in a cup, and when you are not able to drink that milk because its temperature is very high, so what you do, you put a little amount of that milk in a katori or somewhat a kind of a plate which has a larger area as compared to the glass. Yes. So why are you able to do this? Because we know that evaporation is a surface phenomena. That means it depends on surface. If surface area is high, then evaporation rate will also be high. So you know that when you have a cup and if you have a saucer, where is the surface area more? Of course, in the saucer the surface area is more as compared to the cup where the surface area is less. So definitely the evaporation process will be higher in the saucer. So if evaporation process is higher, so cooling will occur faster. So that means your milk or your hot tea will become cooler soon in a saucer as compared to a cup. So these were some of the questions which were from your NCERT book, which I thought that might be difficult for you to understand. So rest of the questions are easy, you can do it by yourself. This was our last part of matter in our surrounding. In next part we are going to start with biology, the fundamental unit of life. So I hope you will see those videos also, and please like and subscribe our channel.